we decided that it would be much more interesting if I was actually to provide some entertainment value for you. So if there's time, I will do that at the end. But instead, I'm going to start off by talking about making push on green a reality. And I'm not so much going to be talking about creating push on green, but rather what you need to get before you can get push on green. It's an evolutionary process. It takes quite a while. And here's who I'm anticipating my audience to be. You maintain a production service of some form on one or hopefully more servers. But this can be done with one server. You have one or possibly more environments, such as a sandbox environment or a test environment and your production environment. In other words, you don't test on prod. But if that's the way you want to roll, OK. And you have 0 or more dependents or dependencies. Now, in the world that I live, we work in a rather large stack, and we make changes which affect end users and other teams make changes that affect us. And so the dependencies are rife. But this may not be the case for you. You may simply be dependent on libraries. With whatever your development environment is, you need to make some form of updates, and you have a limited tolerance for failure because if your production service fails, then your users are not happy. Whoever your users happen to be. It could be a web-facing system where you have clients. It could be an internally facing system where you have users within your company, but by and large, people are not happy with things breaking. So how can you do things safely? Before we can talk about how we can do things safely, since we are talking about going towards push on green, I want to talk about what is push on green. Push on green is when a human or a build system plus a test suite or a human plus some form of live monitoring says, yeah, that looks good, go ahead and roll it out. And now you've got to roll it out and make it available to whoever your client base is. The problem is reality will intrude on your system. You're going to read and write data, which other people are going to write and or read, and so you've got data dependencies. You're not alone because there are dependencies of all sorts of kinds, and you may not even be aware of all of them. You may have a network dependency that you're not aware of until all of a sudden somebody launches something that starts using network resources, and oh, your system breaks because the latency is too big to get certain critical RPCs working. So dependencies exist everywhere. You're going to support and or use APIs that are going to change. You're going to suddenly realize, oh, we need to add this new flag, and you better make sure you do it in a way that doesn't break all of your downstream dependencies. Or somebody else is going to say, hey, I've just added a new flag, and you break. So how can you do cross-testing? And things are going to break all the time. And as system administrators, you realize that no matter what you do, well, you just change that one little thing and something unexpected happened. And when you've got hundreds of engineers changing things, then those unexpected things happen on a regular basis. So how can you avoid rollout pain? When you want to bring up a new service or a modified version of a service or a new API or anything, how can you avoid the pain of failure? And with failure, the wrath of your boss and the wrath of your users and the shame that goes with it. And no matter how hard we try, we all hang our heads at some point or another and get to write the post-mortem. More on that later. So how can you avoid it? It involves a cross-cultural mindset that includes the development system, the testing system, the monitoring system, and the way you do updates and rollbacks. So let's take a look at each of those. When you do development, and by the way, what I'm talking about is how we do it at Google, but that doesn't mean that Google is the only company can do this. When I described who my audience is, you'll notice it was one or more machines, one or more service, not thousands of anything. I work at a company that happens to have a lot of stuff. I did a hardware ops engineer exchange at a data center for 2 weeks. And do you know how much stuff there is in a data center? I'm allowed to say that there are thousands of machines. The reality is, it's almost unimaginable, but you don't have to be at that scale. You can be a site that has 5 machines. You can be a site that has 1 machine, and these will apply to every development environment. And we do it at Google because it's a good way of doing it, not because we're at Google scale, but because it's a good way of doing it. And you can become better by doing things like this. So with development, all your code changes have to be peer reviewed. Nobody makes a change and just checks it into the code base. Nobody. By the way, by that I mean nobody. Yes, there are certain exceptions. Oh my God, there's a critical change that has to be made to the production rollout. Push it now and then it has to be reviewed later because it can be rolled back. But if production is broken and you need to change something right now to fix production, yeah, that's an excuse where you're allowed to make the change. But, oh, customer X really wants this new feature tomorrow. I'll just patch it in. Never happens. Everything has to be peer reviewed. And that's a cultural mindset. And it has to be reviewed not only for code correctness, but also for the tests that you've written to ensure that the code is correct, and also for readability to ensure that it's comprehensible and well documented. You have to get into that cross-cultural mindset of you're not the smartest guy on the planet, that other people are smart too, and if they give you a reason why you ought to change something, you really need to listen to them. And yes, you can disagree, but there has to be peer review. You also have to test your code. Not only do you test for expected conditions, but you test for the unexpected ones. Does it fail gracefully? Raising an exception may be the appropriate behavior if that is the behavior that's documented, but raising an unexpected exception is probably not good because then your code stack is going to crash somewhere. So you need to behave appropriately, and you test that you behave appropriately. And new modules, new libraries, new APIs are developed all the time. There are people who are responsible for migrating tools so that they use the new systems. So you're not stuck one day, like I am at home, saying, you know, I'm running 4.8 BSD on my server, and it works just fine, but God help me if I have to change anything because nothing's compatible anymore. And I could have fixed that a number of years ago, but I was too busy and didn't get around to it. And now it's going to be really painful instead of being a little bit painful at each shot. So there are people whose job it is just to keep you abreast of new technology. And when you make changes, there are people whose job it is to deprecate the old technology, make sure that it isn't used anymore. And that's a cultural mindset. We have a lot of testing, and we have, in some cases, test-driven development, which means sometimes you write the tests before you even write the code because you know what the code's going to look like because the API is specified, so you can write the tests. Now, the tests probably won't work when you actually write the code because you've gotten something wrong in the test, but at least you're halfway there. If there is a bug that you have found, you first write a test that reproduces the bug, then you fix the code, then you rerun the test, and oh, guess what? The test now passes, whereas previously it failed. So you get in the mindset of testing. People write often more testing code than they write real code. And this slows down the process and means that you don't develop as much code as quickly, but the code that gets put out is a lot more reliable. Anybody ever hear of OpenSSL? Right? Yeah, and that heartbleed thing? You ever take a look at the code base? It's pretty appalling. It has about 5 tests. Can I make an SSL connection? Can I make a different kind of SSL connection? Can I make another kind of connection? And can I pass encrypted data? And there are hundreds and hundreds of small modules, none of which are tested. So how do you find out if the code works if you make a small change? Well, I can make an SSL connection, and that tests how much of the modules in the intermediate stack? You don't know. So good testing consists of unit testing and module testing and end-to-end testing and smoke tests and probers. Here's the running code. Go ahead and kick it every now and again to ensure that it's still running. And most importantly, regression tests. Regression tests are nothing more than, do all of the tests which are affecting the currently changed code and not changed code still pass? Does anything in the dependency tree fail as the result of a change that you made? Now you can do this, make all, right, where all includes tests. You can also be a little bit more intelligent about it by calculating dependencies, but if you don't write tests, you can't run tests. If you don't run tests, you can't know what broke until, oh, heartbleed, or something equally bad, or your website goes down. You also need to have monitoring. You need to watch what your systems are doing. Now that's different from profiling. Profiling is where are the hotspots in your code. Monitoring is what's your code doing right now? And some things that you do want to monitor are volume, latency, and throughput. For example, how many hits is my web server getting? And what is the mean response time, and the min and the max response time, and the average response time, and the rate of change in response time to certain classes of requests, and how fast is data flowing back and forth? And if you look at that, then you can go ahead and get historical data. And then you can go ahead and graph that data, and then you can say, oh, look, something weird is happening here. Or, oh no, our load has just increased and our latency hasn't changed at all. Wow, we're really smart. Wait a minute, are we really smart, or are we simply failing to serve something? Well, let's look at how many errors we're getting. Oh, we didn't log that. Well, you probably ought to log that. In a modern system, literally millions of things are monitored. This is not just at Google, this is elsewhere, but literally millions of things. So now how do you condense that down? There will be another invited talk on taking those million things and condensing them down so you can get meaningful data. But if you don't monitor, how do you know what's going on? Do you wait for a user to say your website is slow? That's the bad answer. Do you wait for somebody to notice that the website is down? That's the worse answer. Or do you have alerting, which says, hey, look, we're getting kind of slow here. And in order to know that you're getting kind of slow, you need SLAs, service level agreements. We agree internally that we are going to respond with a certain amount of time to a certain throughput with a certain amount of latency and a certain amount of volume and so on. And in order to get SLAs, you also need SLOs, service level objectives. And in order to get SLOs, you need SLIs, service level indicators. What is the indicator that we are setting an objective to that we agree we will do better than? If you don't have the monitoring, how can you alert when something's wrong? How do you know what is wrong? So you need to add that in. We also need to be able to do updates and rollbacks. And the update is a mechanical process. And there are a couple of steps that you need to do to make that work efficiently. One is static builds. Right? Well, we have shared libraries. Yes, but if you have a shared library and somebody checks in a new version of the shared library, everything that depends on it might break at once. That can be bad. By having static builds, then I depend on library version whatever, and if the library changes, I still depend on that static build. Changes to the library won't break me when I don't do a rollout. If I do another rollout with another build, I might break, but I can test that ahead of time because I've built things statically. You also want to contemplate having human-readable version numbers. Version 12.3.17 is great, but from when is that? You need a table to look things up. So another way is for each component, give it a dated version number. Because I know that 2014-11.12 is on a particular day and release candidate 2, but the build was on 11.12. And now I don't need to have one more table of indirections to look up when something happened. And I also don't need to know that there was no 3.16. We went directly from 3.15. Now, of course, I do need to know if I'm rolling back what date I want to roll back to, but this then adds in another component. You don't push version numbers. You mark a version number as being the live one or the one to push. And then no matter who does the push, you get the right version. There's only one mark. There may be multiple roll forwards or roll backs to a particular version, but only one place do you say, mark this one as good. So then when you roll out, it's really easy. You roll the production version. Somebody sets that, or some tool sets it, but it's in a one place. It's not a single point of failure. It's a single point of accountability. You also want to correlate your rollouts with your monitoring. If I've just done a rollout to a new version, I want to have some way of indicating, not by going, yeah, I think it was over here, but rather by having another graph component where you can see here was a rollout. And look, that is exactly when we saw the inflection point in the behavior of something. It's probably that thing. Or we did a rollout and then 12 minutes later we saw an inflection point. Well, if you're in a system with lots of dependencies, odds are it wasn't you that caused the problem, it was somebody else. So now you can go look at other people's rollout systems and find out who did the push, and you can say to them, hi, when you pushed this new version, we saw a problem. Maybe the problem is bad enough to tell them to roll it back. Maybe the problem is just bad enough that you want to investigate what's going on. Rollouts also need to be automated so that it's not a person typing a bunch of commands over and over again, because you know how that's going to work. They're going to typo something or they're going to get it wrong. And they need to be idempotent. In other words, if I roll out my tool 2014-11-12 RC2 twice, the second time nothing changes. It's already there. Every push component does nothing because it's already done. If it's not idempotent, then where are you if something fails? What do you retry? The easiest thing is just do the whole thing over again. Anything that's a no-op is a no-op. Anything that needs to be changed will change, but there are no if-then-elses. It's just do this, do this, do this, and they wind up being no-ops or not. Another really useful thing for rolling out safely is the notion of a canary job. A canary job is in the case where you have more than one machine or more than one process running things. And you say, some amount of traffic is going to go to the canary job, and the canary job will have the new version, and everything else will have the old version. And then through load balancer, through script, through whatever config file you have, the canary gets some fraction of the load. Now, when you bring up the canary, the first check is, did it crash? Okay, it crashed, let's not push any of the other jobs. That one's an easy one. But if you have monitoring of your canary jobs, then you can let them get some fraction of the traffic and look at the monitoring for the canary jobs to see if there's anything anomalous. You can normalize your graphs so that independent of load, you can compare the canary job with the non-canary job and see if there are any noticeable differences. Of course, there are going to be little differences. The graphs are always going to be noisy. Nothing is ever clean. But you can look at trending and see whether the canary looks good. And if the canary looks good, then you have a good chance of getting everything else to work. If the canary looks bad, you adjust the load balancer, you change the config script, or you simply turn off the job, and everything goes to the real jobs, not the canary jobs, and the users only see a very small outage. And only a very small fraction of those users ever stood a chance of seeing an outage. Again, this is easy when you're talking about things at Google scale, but it's not hard at non-Google scale. The other thing is a rollout is pushing stuff forward. Well, a rollback is pushing stuff forward to an earlier version. There should be no difference. Now, that's a nice optimistic thing to say, because if you have database schema changes, life gets weird. So they have to be managed very carefully. But rolling something back is not undoing. It's simply doing to an earlier version. And when you build your rollout process to understand all of that, then your life gets a lot easier. So how do you do a safe rollout of data? Well, the first thing is you silence some of your alerts. Right? It's a useful thing to say, hey, we're running a mismatched version. You know, some jobs are running this version and some jobs are running the other version, and that's usually a bad thing. But if we're rolling out canaries, we know that's going to happen. So turn off the warning that things are mismatched, and then update the canaries. And immediately run some smoke tests, things that really ought to work for anybody. Go ahead and run them. If they work just fine on the canaries, okay, now you can proceed. At any point along the way, we can roll back, which means roll forward to the previous version. So we run the smoke tests. If they fail, then do you want to roll back or not is a decision that we can ask. If they do work, then let the canaries soak. Soaking simply means let them run for a while. Now, what's your particular environment? Maybe the cache needs to get hot. Maybe you need to write or read a certain amount of data on disk. Maybe there are cumulative errors because this particular component will handle 15 kinds of requests and 14 of them happen 99% of the time and the 15th one only happens 1% of the time. So really the number of times the canary is doing that one problematic thing doesn't happen very often, and you gotta let it run for 6 hours just so that it does enough of them to make sure that they all work. There may be many reasons why you need to let a canary soak. Once the canary soaks and you're happy with its results, and this may mean looking at the graphs, looking at the monitoring, looking at the alerting, looking at the log files, looking at who knows what, once you're happy with that, then you push the remaining jobs. And, oh yeah, run the smoke tests again, because you never know what else happened while you were watching your canaries. Somebody else may have done a different rollout. And when everything is finally done, then you unsilence your alerts, and life is good until something breaks, because it will. So now how do you make software changes? And this rather complicated looking diagram is a rather simple process, but it means you have to take things cautiously. So let's start. We start off with server binary version 0, and we want to introduce a new flag that says, hey, we're going to allow you to pay by Bitcoin. So how do you do that? The safe way is, first thing you do is you update the server source so that you define a allow pay with Bitcoin flag, and then all of the code that uses it is wrapped in, if that flag is on, do something. Well, the default value of the flag is false, so we know it won't ever get executed. We compile that binary, we roll it out. What will happen is the default value of the flag is false, the code that activates if the flag is true, therefore will not get activated. In theory, the binary is exactly the same. We push out a no-op binary, in theory. Once we've pushed out version 1 of the software, then we go ahead and we modify the config files to say, hey, when you push this thing, push it with the flag for all versions of the code, pay in bitcoins equals false. In other words, we are explicitly using the implicit value of the flag. What this tests is that the definition and use of the flag is correct. So it's a little baby step. The next thing we do is, and we roll that out, the next thing we do is we change the canary flag to use Bitcoin, but the main jobs don't. So the canary jobs can do something, but the main jobs can't, and then we do another rollout. If that rollout works, then we change it again, and we say, okay, everybody gets to use pay in Bitcoin. And by the way, there are different ways of doing this. You could possibly also do it with a fraction going and so on. For those of you that are taking pictures of the slides, these are also all available in the talk-in login, so you'll be able to see them there. So we then turn on pay in Bitcoin for all of the jobs and do another rollout. Then the next thing we do is modify the source code. We set the pay in Bitcoin flag to be true by default, because we've been running with that flag true by explicitly setting it for a long time. Everything works. So now make the default value be true and get rid of all of the guards. So since we know Bitcoin is available, since we know we don't need that option anymore, we're just going to use Bitcoin going forward. There are a lot of flags used at Google. You want to avoid having 1,000 flags when you start up a job. This is a bad thing. So as you add features, eventually you make features default. And this is true for any application, right? Remember OpenSSL? You look at how many flags there are. Why? Well, you might need them, yes, and most of the time you don't. So when you don't need a flag, then go ahead and simply change its definition to be true, get rid of all the guards, roll out another binary. When that binary is rolled out a little bit later, get rid of the turn on the flag in the config file and roll it out again. And finally, get rid of the flag definition because it's not being used in any of the config files anymore. And now you have the code which allows payment by Bitcoin that is firmly embedded in the final binary. This process may take weeks. And there may be many of these going on simultaneously. But the point is that the addition and changing of a flag is safe because at any point, all you're doing is rolling back one little thing. You're not rolling back cross dependencies. There was a question from the audience? I'll repeat the question, but future, use the mic. Go ahead, just help me what?
Why do you remove the guards and the define in 2 steps?
The question was why don't you remove the guards and the definition of the flag in 2 steps? Sorry, why do you do it? You want to change as little as possible and not have cross dependencies. So if you remove the flag definition, then the use of the flag inside the config file, we already say all Bitcoin is turned on. If we remove the flag, then that will generate an unknown flag error. So what you want to do is you want to leave the flag in place so that the config files still have valid values. And you can roll back 1 step easily enough because all you're doing is rolling back a binary or a config file change. If you change both of them at the same time, then you have problems. Because let us say that we have 3 flags and they're in different stages, and we simply want to roll back one use of something. If the binary is bad, you're changing all 3 flags, but if simply the config file is bad, you only need to change 1 flag, and it removes the amount of dependencies that you have. So it's complicated, and you have to think it through. And this is a process that has been evolving, but this is now accepted process as being the safe way of bringing in a new flag. So when I talk about configuration changes, there are 2 different kinds. The one I just showed you, which requires job restart, which has runtime flags, but it's also possible to have config file changes where you simply hup the job and it rereads new configurations. And obviously, that one's going to be a lot neater because you can make changes much faster and not have to roll out lots of different jobs, but it's also much riskier because the changes happen that much faster and you got to be really careful how you roll things out. So there are pluses and minuses for all of these. But I do consider both of these in my notion of how to do a safe push. The result of doing things safely and doing things small and thinking about monitoring and thinking about testing and getting this cross-cultural mindset has meant that when I started on this project in 2013, we were doing on the order of 12 rollouts a week. And as the thing progressed, we got as high as 75 some odd rollouts per week. And these were all human curated rollouts. So an order of magnitude increase in the number of rollouts that we did. And by the way, we also wound up freeing up a full-time engineer. Did more rollouts with less manpower because we were automating it. Now, of course, there's a lot of work in getting the automation, but if you think about it and work at it, this is the kind of improvement that you can see. Do you need to make changes this fast? Depends on your service. But do you need to make changes that safely? Does not depend on your service. If you want it to work, you need to take lots of care. So our process has improved to include things like automated recurring rollouts. We simply run a certain kind of rollout every single day. Well, not every single day. It's multiple times a week, and a week is really 4.5 days long. We're SREs. We're sysadmins. We like our weekends. We carry our pagers over the weekend, and on my service, it's a 5-minute SLA. That means from the time the pager goes off until time I have hands on keyboard, VPN'd into the network, working on the problem, 5 minutes. So before you take a shower, you make sure you're connected. Because if the pager goes off, which you do bring into the bathroom, and you take a shower and the pager goes off, you leave. You have soap in your hair. Tough. We like our weekends as a result. So the automated rollouts don't run on weekends, and we also really don't like pushing things on Friday afternoon, because that can ruin your weekend also. Right? I've had cases where somebody said, but I sent out a note that I was pushing. It's like, yes, and I was the one who was up till 2 in the morning fixing things. No fun. We have inter-rollout locking, because some rollouts affect things that other rollouts affect. And you want to make sure you're only doing one of them at a time. We have schedules of rollouts. So the automated rollouts that are run all the time also adhere to a schedule that even though we could roll them out at midnight, Let's not do that. Let's wait until 9 in the morning so that if something is scheduled, it will automatically get run at an SRE-friendly time. And yes, if our pager goes off and we have to do a change, we'll do it whenever it needs to be done, but why make our life more miserable? We also have one-button rollbacks. So if you do a rollout, the rollout itself knows what the previous version was. There's no human memory involved. If it isn't good, push the button, and it rolls back. Actually, like I said, it rolls forward to the previous version, but it's really easy to do. Now, what this enables us to do is have much more frequent, smaller rollouts, and this helps developers. They don't have to wait for the weekly build. They can introduce config file changes and have us do a rollout that makes those changes fairly frequently. And we don't mind doing it because it's a number click, number click. We don't have to sit there and type all the commands. So our job is easier because the process is automated, and their job is easier because although they have still tested a lot of things in the test environment, they are able to go ahead and test it in production that much faster because they're not waiting for the weekly rollout. So what are we looking at for the future? Because I did talk about issues and consideration of working towards push on green, because we're not there yet. We've been working at this for a while, and we still don't have the magic silver bullet automated process that we want to have, but we're a heck of a lot closer. So for the future, we want to do things like rollback feasibility. If you're going to roll out a new version, how easy is it to roll back? If there are database schema changes, that starts making a big impact in your feasibility. If it's just a binary change, rolling back is easy. But as soon as you include data, now life gets weird. So testing for rollback feasibility. We ultimately want to work towards continuous delivery so that if there's a change in the binary or a change in the config file that has been checked in, roll it out. Just constantly roll stuff out so that the humans are not even involved anymore. We also may want to have rollout quotas, because if somebody is testing lots and lots of features, they may be starving the queue for other people, or they may be doing bad coding practices, or who knows what. But we might want to introduce rollout quotas for a person, for a team, for a tool, who knows what. And we also want to introduce the notion of rolling out green on green. If you have continuous delivery and something breaks, do you want to roll out the new version automatically and make it more broken? We still need a human in the loop. And we've discovered that all of these really cool ideas that we have are simply part of an evolutionary process. And we've been working at it for a while, and we're doing things slowly because things will go wrong. They go wrong every day. Not always pager level wrong, but things break. So the way to fix that is to adjust attitudes. People have to understand that, yeah, bad things happen. Okay, what next? And when something bad happens, what's very important is you find the reason for the problem so that you can document it and not to punish the person who caused it, because mistakes happen. That guy who did that rollout on Friday, he came in on Monday fearing that he would be fired. And I said, no. Stuff like this happens all the time. Your punishment, if you want to call it that, is you get to write the postmortem. And the postmortem documents what went wrong and why. And that prevents it from happening again, because in addition to that, we also introduce changes to the process so that it can't happen again. My first week as a full-time SRE actually doing things, I brought down the service. You know, bad things happened. Okay, I had to fix it. And the way I fixed it was preventing the thing that I did from ever happening again. Simple software change. The hooks were there. They just hadn't been used. Well, now they're in there. So we fix processes instead of blaming people. We allow the humans to be smart while allowing the machines to do the repeatable stuff. Why have humans do repeatable stuff when we have computers to do that for us? But because the humans are smart and because the humans are in the loop, we also encourage people to go with their gut. If it doesn't look right, if it doesn't smell right, if it doesn't feel right, push the big red button and roll it back. And you get to learn when's an appropriate time. But if something might be broken, if you roll it back, what's the worst that happens? You roll it forward again later. Big deal. The new release is delayed by some amount of time, and chances are the users aren't going to notice anyway, but they will notice the outage, and they will notice the problem. So if it doesn't smell right, push the button, because you can always fix that again later. And you learn to judge when it doesn't smell right. So what if you're not at Google? Right? We've got this big infrastructure, we've got this big team or set of teams. What can you do? Well, it's really simple. You change the way you do development so that you have that test-driven development, so that you have the peer review, so that you have the nobody just checks in that one little change mentality. You change the way you do testing. In fact, you do testing. You write tests that can be run in regression testing. And yeah, it's a pain, and I hate it, and I do it anyway, because it makes everything so much better when something goes a little bit pear-shaped. You have to put in monitoring, and there are lots of tools for doing this. Cacti, MRTG, and so on. And even if your tool can't be instrumented directly, there's probably some API or even command line interface. I mean, SendMail, for goodness sake, has a thing that says, show me how big the queue is. So you write a little wrapper that asks for how big the queue is and turns that into a table of numbers which get monitored, and now you can watch what your SendMail is doing. And you can see when your queue is backed up, just based on SendMail stats. So it's possible to monitor anything. And you need to have a mechanized process for doing updates and rollbacks. It's just a cross-cultural mindset. And if you're a one-developer shop, you can still do it. It's just a lot of work for one person, but you can do it. There are no silver bullets. I'm sorry. You know, I can't say Google's next product that we're going to give you is a push-on-green system, because it's dependent on the tool. But you can do it. It requires lots of baby steps. Now, here's an interesting factoid for you. I walked 178 miles last month. I walked over 1,400 miles last year. How did I do that? One step at a time. I didn't notice it. I walk to the cooler, I walk to the cafe, I walk up and down the stairs. It adds up. All of these little changes that you make to your rollout system, all improvements, will add up, and it will make it better. And you too will be moving towards push on green. But you got to be careful, and you can't take shortcuts. You can't just check in that one little change because it's not going to hurt anything, because, yeah, it could. And then you wind up with egg on your face. Keep going. You can do it. We did it, and it's only because we drove at it that we got as far as we did, but you can do it too. And that's the basic idea behind the talk. You can get towards push on green. You just got to work at it. Thank you. So I will be happy to entertain any questions. Yeah, in the back. And could you use the mic? It will make life easier for the recording system. If you queue up at the mic instead of raising your hands, then it's pretty obvious who's next. And it will be working in moments. The sound guy is scrambling as he is fixing that one little thing that he changed that shouldn't have broken anything. It's probably the switch on the microphone. Watch me freak him out. Sorry. By the way, I did promise that I would do the interpretive dance, so while he's fixing that, I will. So if you want to push on green, it's legal in state of Washington, then you have to test, and you have to beat yourself, and you have to make sure that it's repeatable and mechanizable, and then everything will work fine. Okay.
So how many phases do you roll out in? I mean, I assume you don't roll out all to 2%, 10%?
So you're asking for specific numbers, which I'm not allowed to give you under any circumstances. But what I can say, no, it's okay. But we do have multiple environments. And the typical environments that you will find are there's a development environment, a testing environment, maybe a sandbox environment, maybe a backup environment, and a production environment. And this is true in any organization that has large numbers of things. number of phases, ratio of canaries, that's going to depend. But it might be the case for a very mission critical system that you would roll out fractions of percents for the initial canaries. It might be larger numbers, 10% or so. My personal recommendation, having nothing to do for the company that I work for, is somewhere between fractions of percent and 25. Mm-hmm. And that's a range, but it's going to depend on what you actually do. Did that answer the question?
Yeah, and
Okay.
I assume a rollback will happen automatically if it fails. If alarms start firing, whatever.
Automatic rollbacks are problematic, but not impossible. Uh-huh. But when you do a rollback, you won't roll back in increments.
No.
So you change the mechanism of rollback. So if you have rolled out the canaries and say it's time to roll back, you roll back the canaries. If you've rolled out the canaries and then have rolled out production, you just roll back everything. Because the canary jobs may or may not be different. You just say, fine, everything goes back, and don't bother with the incremental steps.
Got it. Thank you.
Sure.
Just to follow up slightly on numbers I can give out from my organization, we go for like 2 or 3%, something like 1 or 5% to test. We have found that there's not any difference between like 10 to 20% and 100%. There's no point in 50%.
Yeah, and it depends on the service, but
yeah,
yes.
So after a few percent, you've discovered it's broken, and then you turn it full on or do 50-50 and measure conversion or that kind of thing.
And the times where it might make a difference is in a multinational or multi-browser support or multi-region where you're getting different classes of requests. But you're right, in general, you'll notice that it's broken or not.
So my actual question was, in your canary setup, you must be directing people to the canary consistently, so they always get the pay in Bitcoin option as they navigate the website or whatever. Do you have any comments on setups that don't involve that, if any?
Well, I was thinking about how could you do this if you were a shop that had one Apache server and running a CGI script. And you could have a CGI script which ran the real CGI script, passed it all the environment variables, and all that the front-end CGI script did was look at a config file, so that it said, job or all equals 100. And then when you wanted to run canaries, it would say job equals 99, canary equals 1. And then it would simply roll a dice to decide who gets what. So it doesn't have to be done with a load balancer.
So if you have user sessions or something, then it can throw the die for each user.
It depends on what exactly you're doing. But if it's session-based, then you're passing the session key each time. So does it matter that some of the sessions go to the canary and some don't? Depends on what change it is that you've made. So yes, maybe you do need to have session key logging also.
Okay, thanks.
Any other questions? Okay, thank you very much then.